Okay, here's my effort at the Pixi 2A predicted paper for the 2023 exams. This is the Edexcel questions. Oh, I guess what Edexcel papers might look like. Right, so okay, we're starting off on number 1, writing as a product of primes, 180. Product of primes, I will start with 2, so I try to do prime numbers in order. So start with 2's 90, so 10 times 90, 2 times 45, 3 times 15, and then you've got 3 times 5 is 15. So the product of primes, right, as a product with prime factors, 2 times 2 times 3 times 3 times 5. Now I know a lot of people say to me this should be 2 squared times 3 squared times 5. I personally prefer it like that one, unless the question says write as an index form. That's how I'm writing it. Okay. Product of its primes. Right, okay, Martin thinks of two numbers. We do Venn diagrams. I do Venn diagrams for this thing. The highest common factor of the two numbers is 6, so I'm going to put a 2 and a 3 in here to represent the 6. This is normally filled with prime numbers. The lowest common multiple of my numbers is a multiple of 15. Now, the highest common factor goes in the middle. The lowest common multiple is when you times everything together. Now, if I want 15, I'm probably going to put a 5 in a box, and this is going to make me a multiple of 15. So then I can put anything I want in here or nothing. I'm going to put nothing in there, and I'm just going to have 2 times 3 being 6, and the other one's 15. The other one would be 2 times 3 is 6 is 30, wouldn't it? So 30 and 15 would work. Let's just put another number in there. Normally I pick a prime number, and as long as it's a prime number that's not over here, then we should be okay. So I'm going to put, I don't know, 2, 3, 5, I'm going to put 7 here for no reason. So that means my two numbers are 2 times 3 is 6 times 5, 6 5s are 30. 2 times 3 is 6, 6 7s are 42, and the highest common factor of those two is going to be 6, and the lowest common multiple is going to be a multiple of 15. So it's whatever that turns out to be. Right, next one we've got on activity day. We've got football, hockey. We've got boys and girls. So it looks to me like it's going to be a two-way table job. So let's just do a two-way table. We've got one. So we've got hockey, football, and tennis. And then we've got 4 columns here because we want a column for the total here, total here. There's students are boys and girls, so boy there, girl here. And then we've got football, hockey and tennis. And then we can start filling in. We've got 120 students altogether, so it goes there. 30 of the students are boys, so 30 there, which makes this one 90. So that's the first one I've got to work out, so I'll just put 90 there. Next one, 12 boys and 26 girls play hockey. 12 boys and 26 girls in the hockey column gives me a total of 38 going down here. That's 38, isn't it? 45 students play football, so in football we've got 45. So now I can go with this number over here. Where's my calculator gone? I'll use that one, I think. Right, so here's a calculator, so it works. So we've got 120, take away the 38 and take away the 45, gives me 37 in this box over here for the total who playing tennis, is it? Yeah, tennis. 35 of the 45 students play football, 35 are girls, so 35 are in there. That gives me 10 up here, and that gives me 10, and 12 is 22, that gives me 8 over here, and then 37 take 8 is 29 over here. Okay, so they're the numbers I've worked out once I've put in little, well, they're called speech mark type things, quote marks. Work out the number of girls who play tennis. Girls on tennis is 29, so that's just 29 at the bottom then. Okay, just a quick two-way table on that one. Next one is a construction. Obviously I haven't got my compass, so that's an irritation. The way the compass would work is you put your compass point here and you just draw a big arc in the centre. You put your compass point on this one, you draw another arc, and then you can draw a line through the 2 points where they cross over, and that would be your centre point. I don't like the fact that I don't have compasses on me. I don't have a compass. It's irritating. Sorry about that. Okay, Gemma has the same number of sweets as Betty. So this finishes with that line, doesn't it? So the line straight down the centre. And what you could do to check is, if you wanted to, you can measure that distance and measure that distance, and it should be the same distance. Right, okay. Gemma has the same number of sweets as Betty. If let's say she's got X number of sweets and then Betty's got X number of sweets, but Gemma gives 24 of her sweets to Betty. So now she's got X take away 24 because she's given over here. So Betty's now got X plus 24. Betty now has, so Betty's X plus 24 is equal to 5 times as many as the other person, X minus 24. Okay, work out the total number of sweets that Jamie and Better have. So we've got, what's that? So it's x plus 25, let's just expand that bracket. 5x take away 120. We can bring the x over here to make it 4, so we just take it away, you get 4x. And then you add the 25 over here. Something's going wrong here. Oh, I don't like this, I don't like this. Why have I got 25? Where did 25 come from? It should be 24. 24, and that should be 24. Right, rewrite, not overwrite. Okay, so add the 24 is 144. Where did I got 25 from? Just my brain working overtime. Divide this by 4 is 36, isn't it? So x equals, must be 36. Now the total number of sweets that they call it, where I got the total number of sweets that Gemma and Betty have is just 2 lots of x's, so you've got 72 sweets in total, which have been shared out. Okay, next question. We've got 55, 45, now I'm going to try and let's finish this off, 55, 45, and that makes this one up here. So what's that? That's 90, that's 100, so that makes that 80 up there. This one, there's nothing exciting going on there, nothing exciting going on there. There's an 80, there's a 45, this one's 55 down the corner. 4 triangles. 2 of these triangles are congruent. Now for congruency, we want all the sides to be the same, and now we don't know all the sides on any one. We want a side, an angle between the sides, and then another side. So we need 2 sides and an angle, 2 sides, but we don't know this angle, so we can't use the rule there. 2 sides, but we don't know this angle, only 1 side there. ASA is the other version. ASA is a side and 2 angles coming off that side. So you've got a side there, 10, and 55 and 45 are coming off it. A side there, but only 1 angle, don't know that one. Side there with no angles, can't use that one. A side there with only 1 angle. A side there with 2 angles coming off it. Now let's just check that. 10, 55, 45, 10, 55, 40, 55, 45 in some order. These 2 are going to be congruent, A and D. The other version of this rule, SASA, SAS and ASA, is AAA, but where all the angles are the same, that's actually a similar triangle, not a congruent. Congruent means exactly the same, similar means it's an enlargement of the other one. 152 million in standard form, so that's 152, then 6 zeros, 1, 2, 3, 4, 5, 6. So that's going to be 1.52 times 10 to the power of 8, not 6, because you've got to come back the 6 zeros, and you're going to come back the other 2 to get past the 52. Now I move the decimal point, which people tell me off for, because you're supposed to move the number around, never mind. This is an ordinary number, is 0.00. It's easy for me when I say a negative, because it just means decimal, and the 3 is zeros, and then the 24. Sorry, the 2.4. The other way to think about that is minus actually means divide by 10. So even though it says times, it actually means divide by 10 3 times. There we go. Number 7. We've got the shop. We've got packs of pens sold. So this is the packs of pens, not the number of pens. So if I look at the number of actual pens, so we've got 7 black. Black was 2 pens in a pack, so that's going to be 7 2s of 14. And then you've got 3 5s of 15. And then you've got 4 green, 4 6s of 24. So this is the number of pens now. So that's the number of pens, not packs. Okay, so that's our ratio there. The total number is 212, total number of pens sold. So if I add these together, so 14 plus 15 plus 24, that was weird, I put a 2 and a 4 together there, 24 equals, what's like 43 or something, let's have a look. 14 plus 15 plus 24 is, not that takeaway, equals 53, see, I got that wrong, because I'm a muppet, and I actually got to use a calculator. And then I've got 212 divided by 53 equals 215, I put 215, I'm just writing everything wrong. 212 divided by 3 is 4, so now I need to multiply all these by 4, so I'll get 14 times 4 to 15 times 4 to 24 times 4, which is 56 to 62, 80, 96, isn't it? And this is black, red, green, so we've got black, red and green there. Work on the number of green pens, 96. Green pens were sold there. I'll try to stop making mistakes in a minute. Right, Tariq buys a laptop. He gets a discount of 95% off the normal price. So he's actually paid 95% of the normal price. Tariq pays $551 for the laptop. So this is where the $551 comes in. So we're trying to get the 100% price. So I'm just going to divide by 95 to get 1%. And then I'm going to times it by 100 to get 100%. And that'll be the final answer, won't it? So there's my 100%. So I just get the calculator now, so 551 divided by 95 times by 100, and I get the answer. £580 is how much it actually cost to start with. Joan invests £6,000 in her account. The savings account pays compound interest at the rate of this thing after 3 years. So she's gone 6,000 times 2. No, it isn't. It's 1.024. Why is it that? Because 100% plus 2.4% is 102.4%. So I'm multiplying by 1.024. And then for every other year, you've got 100% plus 1.7% equals 101.7%. So now we're going to multiply by 1.017 for a further 2 years. So we square that one. Okay, because 3 years, there's your first year, there's your second year, and your third year is the squared bit. And then it's just get your calculator and go for the question. So we've got 6,000 times 1.024 times 1.017 squared equals, and there's the amount. So work out the value of the investment, just important to write that, 6354.671 going off forever. So £6,354.67 is the value of the investment. Next one, we've got looks like circle theorem questions. Let's go for this one. Work out the size of the angle. You must show your working out. So showing your working out is different there, giving a reason for each one. So I'll explain the reason, but I'm not going to write it down. Showing the working out is really just putting the numbers all over the picture. Now, I think first thing I'm looking at seeing is this thing here where I've got this 56, and that 56 can come over here as well. 56 degrees can go there. And that's a thing called the alternate segment theorem, where if you draw a chord and the tangent, there's a chord and the tangent, then the angle that comes off this chord inside this thing has got to be the same as that one, and that's called the alternate segment theorem. But there we go for that one. So that's 56. This one in the centre here now must be double that one, 112, 112, because the angle at the centre is always double the one at the circumference. Next thing I notice is this is going to be a right angle triangle, not right angle triangle, what they're called, isosceles triangle. This side is a radius, this side is a radius. That makes it an isosceles triangle. So if I do the 180 for the triangle and take away that 112 that I worked out, and then divide that by 2, I get 34 degrees in here and 34 degrees in there. Now the alternate segment theorem can work on this way. So this angle here, this one, so angle off this one is these two together, so that must be 39. Oh no, 39, what's that about? Must be 69 in here, adding these two together is 69. I make loads of mistakes this paper. And then the last thing I'm looking at is the radius and a tangent is 90 degrees, so that makes that one 21, because 21 and the 69 is 90 hopefully. Right, what am I looking for? I'm looking for C8O, C to A to O. I was looking for that 21, and there's the 21 down the bottom. Okay. Next one, a car travels 18 minutes at an average speed of 72 kilometers an hour. Now, 72 kilometers an hour, 72 kilometers in 60 minutes. That's what 72 kilometers an hour means. It means you're going to travel 72 kilometers in an hour, and an hour is 60 minutes. Now, I want to get to 18 minutes. Let's go for that one. And it's a calculator paper, so let's just divide by 60 to get to 1 minute, and then times it by 18, and we'll have 18 minutes. So that's how I'm going to do this one. So I get the 72, and I do the same thing over there. So 72 divided by 60, but then times by 18 is equal to 21.6 kilometers. So that's how far she's actually travelled. So the speed for me is 72 kilometers an hour with 72 kilometers in 60 minutes, and then just work from there to get to what I want to. 72 kilometers per hour is faster than 20 meters per second. Now, is it? So how far would you go in 20 meters? So if 20 meters per second, let's just work on that one, see what it compares that one. So 20 meters in 1 second. So if I times it by 60, I'll guess, so times by 60, so that'll be 60 seconds, that's 1 minute. And if I times that by 60, I'll get 60 minutes is 1 hour, which is really what the speed's all about. So I need to times by 60 twice. So I take the 20, times by 60, times by 60. Ooh, 72,000 meters in 1 hour, which is 72 kilometers, as 1,000 meters is 1 kilometer, in 1 hour, which is 72 kilometers per hour. Okay. So is David correct? 72 kilometers per hour is faster. No, they are the same. Okay, next question. Alright, what we're doing, we're going to draw a cumulative frequency graph for this thing. So cumulative frequency, just where you add the frequencies up. So 5 and 18 is 23. Oh no, it doesn't start with 5. And then go up to 23. And now 23 plus the 12 is 35. 35 plus the 4 is 39. 39 plus the 1 is 40. Plot them on the graph. So we always plot them at the end of the groups. So 175, I'm going to go up to 5. So 1, 2, 3, 4, 5. I can't see this very well on the graph. Next one goes up to 23, so there's 20, 1, 2, 3 is there. Next one goes up to 35, so there's 30, 1, 2, 3, 4, 5 is there. Next one's going up to 39, which is here. And the last one goes up to 40. Unfortunately, the cumulative frequency graph looks like an elongated S shape, which is what they normally look like. It doesn't always look like that. I've ever seen them in exams where they don't look like that elongated S. But there we go. Plants have a height greater than 187, so I'm going to find 187. So there's 10 marks, that's halves, isn't it? It says 186, says 187 there. So I'm going to use this bit of a ruler. I haven't equipped myself out very well today. So there we go, going all the way up to that point is there. That's 187's marker. So then I can come across, and I can see that mark there is at 37. So 37 are going up to there. So that means 3 are greater than. Okay, so there's 37 to 40 is another 3, so there's 3 which have a higher height than that one. Next question, we've got a density question, so DMV, so I'm looking at DMV. I want to work out the mass of the frustum. The glass has a density. A frustum is measured by movement across. Right, okay, so that's what's going on here. So I've got this big cone, so the big cone there, and I've got to take off that little cone to get equals this frustum thing. So I've got to do these things, haven't I? So we know this is 12, and we know the height of the whole thing is 15, and we know the height of the little one must be 5, just looking at the picture. So I'm just looking at this picture here. So it's 15 all the way up, that's 10, so the height of the little one must be 5. Now the nice thing here is these things are actually similar shapes, so whatever the scale factor is, it's the same on both of them. So if that's from there to there is times by 3, whatever times by 3 you get to 12, this must be 4 wide. Okay. Right, so now I can start working on some volumes, can't I? Because I'm working out the mass of the frustum, so I'll probably want to say some volume things going on. The volume of the frustum, I've got the density, and then I can work out the mass. So let's have a look. So I want the volume of this thing, take away the volume of that one, so it can equal the volume of this one. So the volume of this one is 1/3 of pi times by the radius squared. The radius is 6 because the diameter is 12. So 6 squared times by 15 times 15. And I want to take away 1/3 of pi times 2 squared times 5 equals going to be that one, isn't it? So it's equal to whatever this is, the volume of that one. So now I can go for the calculator. I've got pi, oops, that's not pi, there's pi, pi times 6 squared times 15 divided by 3, that's the third of that one, take away, let's go again, pi times 2 squared times 5 divided by 3 equals, just press that button, 544.54 going off forever. So that's the volume of that mess. So then we've got DMV. So DMV, the density is 2.5. The DM, the mass is there. The volume we've got is 544.54 going off forever. So the mass equals, multiply these together. So equals times 2.5 equals 1361.35, running off forever, and I'm going to go with 1361.4 is where I'm going to round. The reason I round to 0.1 decimal place is really just because the density was given to 1 decimal place, and it's always nice to match them up. Okay, so that's that one. The mass of the things, it's a bit heavy. Next one, we've got this table where I can estimate what it means. The estimate mean is the midpoint, so that's 5. Middle of those two is 12.5. Middle of these two is 17.5. And the middle of these two a little bit awkward, 20 to 35. So 20 plus 35 is that one, divided by 2 is 27.5. 27.5. And then you multiply by the frequencies. it's all about understanding what it means. It means you've got 16 fives, so I need to multiply and then add. So 16 fives are 80. I've got 18 times 12.5, 225. I've got 17.5 times by 10, 175. And then 6 times 27.5 is 165. That gives me a total of plus 175 plus 225 plus 80. That's giving me a total of 645. And then the final answer is 645 divided by the 50 suitcases it tells me in the question equals, divided by 50, 12.9. 12.9, which makes sense because that's in the middle of these things. So 12.9, passengers have to pay extra money for any suitcase that weigh more than 20 kilograms. So there's 6 other things. 2 of the suitcases are chosen at random. Work out the probability of both suitcases, so we want more than 20, so we've got, it's more than more and more, so we've got chosen at random, so we've got 6 out of 50 times by, in the second suitcase is, there's only 5 left out of the 49 to pick from, if you've done that right, equals 30 out of, and then 50 times 49 is 2450, and we're happy with that answer. I don't need to cancel probability questions down. Next question, I'll draw a histogram for that information. So histograms, let's just draw a quick table over here. So the table of a histogram, there's 3 things to do in a table of a histogram. There's the width of the groups, there's the area, which is just the frequency, and then there's the height, because histogram is just rectangle, which is probably called the frequency density. Just think of these as a bunch of rectangles. Now the width of the first one is 0 to 10, looking over there, which is 10. The width of the second one is going to be 5, 10 to 15, 15 to 20 is 5, and 20 to 35 is 15 wide. The frequencies, so this is also the frequency, is the area of your rectangle. So we've got 16, 18, 10, and 6. And the height, so if that's your area, you do the area divided by the width, you get the height of your rectangle. So that's 1.6. This one's 3.6. This one is 10 divided by 5 is 2. And then 6 divided by 15, I'm just going to work on the calculator to get the answer. 6 divided by 15 is 0.4 for the heights of the things. So now I can just go over here and start putting the numbers on the scale. So going upwards, so this one is 1, there's 2, there's 3, and there's 4 for me. Drawing them on. This is the frequency density, FD, up the side, which is also known as the height of the rectangle. The first group was 0 to 10, wasn't it? So that's going to be a height of 1.6. So 1.6 is there. So I'm going to go across to 10 there. The next group was 10 to 15, and that's got a height of 3.6. So 3.1, 2, 3, 4, 5, 6 is there. And that's got a 1, 2, 3, 4, 5 to there. So that's that one. The next one is with the 5 as well, the height of 2. So it goes from 1, 2, 3, 4 there to there, I believe. And the next one, 0.4, so 20, 1, 2, 3, 4 is 0.4 across to, what was it, across to 25, 20 to 35. So 35 is going to finish there. And now I'll just take my ruler, or my bit of a ruler, which is the back of my protractor, and just draw those in. And there's my histogram. Okay. Bosh. Histogram. 3 points. Just drawing a bunch of rectangles. Right, here's a sequence. First 5 terms sequence, the nth term. So we go differences are 7, then 11, and then 15, and then 19. This is a difference of 4. This is a difference of 4. This is a difference of 4. We divide that by 2 to get 2. This tells me how many square numbers we're going to have in there. The square numbers are 1, 4, 9, 16 and 25. We want 2 lots of them, so we actually want 2, 8, 18, 32 and then 50. And what we do is we just take them out of the sequence at the start with, so go from here to here and I just take them out. So 4 take away 2 is 2, 8, 11 take 8 is 3, 22 take 18 is 4, 37, 32 is 5, 56, that one is 6. So that's going up in 1, so this thing is like your 1 times table n. But you've got to add 1 every time, so it's 1n plus 1. Your 1 times table plus 1. So the overall formula is going to be 2 lots of n squared from this part, and then this bit is plus n plus 1, and you can check, you just run the fifth one through there. You get 2 lots of 5 squared plus 5 plus 1, that's 50, that's 5 plus 1, 56, which is what we were looking for in our sequence. Okay, next question. We've got question 15, our bearing question. Well, it looks like bearings at the moment. The nice thing about bearings is if you've got any sort of bearing question, if you know this angle here, then you know this angle here, because these two will add up to 180 degrees, because they are called co-interior angles. Some people call them allied angles, but they just add 180. So I'm going to put this angle up here straight away. So 180, take away that 37, is 143. So I've got 143 there. Then the angles around this point are 360, take away the 143 and take away the 150. Which is 67 degrees inside there, so that was useful. And then down here I'd have 30 degrees down here as well, wouldn't I? Because 150 and 30 is 180. We've got just a description. 8 bearing of 37, Charlton is 9 on a bearing of 150. Find the bearing of Charlton from Acton, so A to C. So I want to find, I'm going to go this way, aren't I? From Acton down to Charlton, and I want to find the bearing, I want to find that angle there. That's the angle that I'm looking for. So I really need to find this angle here, is where I need to go to. So let's have a look at the triangle now. So now I've got this triangle. I've got 67 up here, I've got 8 and a 9, and I'm trying to find this angle here, but I'm a bit stumped on the angles. So I'm probably going to need to find out other things as well, aren't I? Can I go straight there? That angle, that one, no, because I need this side, don't I? I need that side to match up with that one for the sine rule. So I'm going to call this side A, and I'm going to use the cosine rule to get that side. So A squared equals B squared plus C squared minus 2BC cos A. So that's your cosine rule. So A squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 67. Which equals, and on the calculator, 8 squared plus 9 squared minus 2 times 8 times 9 cos of 67, which is that thing, 88.73 some mess. So A is equal to the square root of that. Square root of that answer is 9.4199, whatever that's going to be. So now I know if I go with this triangle again. I've got 9.4199 something or other. I've got an angle of 67. I've got a side of 9. I'm trying to really find this angle over here, which I'm now going to call angle A. So this is a new setup. And that's all I want. I don't want the 8 there because it'll over confuse things. This is going to be side A, this is going to be angle B, this is going to be side B, and this is my sine rule of A sine B equals B sine A. That's how I like to remember the sine rule. Okay, a lot of people remember A over sine A and B over sine B and C over sine C or something. I like this one, just a slight variation on it. Whack your numbers in. So A is 9, sine of B, which is 67, equals B, which is the 9.4199 thing, sine of A, which we don't know yet. So we're going to do that one divided by that one. So 9 sine 67 divided by 9.4199 equals sine A. So let's go for that thing now. So we've got 9 sine of 67 divided by that last answer that we had earlier is this number. So that's 0.879 whatever is sine A. So A must equal the inverse sine of that one, or arc sine, or whatever you want to call sine minus 1. So shift sine minus 1 of that answer, and I've got 61.57 degrees. Okay, we'll go on further. Now if we go back to the picture that we started off on, going back up to the top, this is 61.57 here now, so you've got 61.57 going on further. So the bearing is add 37 to that one, so we've got 37 plus 61.57 whatever is equal to, so plus 37 on the calculator, and we're trying to get the one decimal place as well, so we've got 98.57. So that's equal to 98.6 degrees, but the bearing, we always have 3 whole number digits, so I'm surprised there's a number there, so 098.6 for the bearing. Okay.